have been a working developer for about 10 years in varying capacities and on varying projects. And about 2 years ago, I moved to the UK with my husband and got a slightly different developer job with a company created and at that time primarily staffed by security people. So the company is called Helical Levity. You have probably never heard of us, and that's okay. You may have heard of the big project that we're working on at the moment, which is the CyberStart application set. This is a set of tools that we've built to teach young people, in particular kids between the ages of 12 and 18, the technical skills behind a lot of what the people in this room do every day. So it's created as a bunch of challenges that starts assuming that you know nothing. It starts very kind of puzzly, cryptography puzzles, little bits and pieces to get you interacting with the browser. It assumes no technical background. And as you go through the 200+ challenges, at the end you're doing very highly technical things, including reverse engineering stripped binaries and all kinds of fun web application stuff. As a result, we have a team of security people and a team of developers who work together in kind of a strange way that you wouldn't normally see at typical web application companies, and that's because some of our speccing is done by our security team because they have to spec out the challenges. They also play a much larger role in the dev process in some cases, building some of the challenges or building the initial concepts, proof of concepts for the challenges. And obviously, if you're building a tool that teaches people to hack, if you teach someone how to do an SQL injection, the very next thing they're going to try it on is the application they're in. So we also have to make sure that the application framework around these challenges is highly secure. So over the last 2 years as a working developer and also working much, much more closely with the security team than I ever had before, it got me thinking a lot about the dev-sec relationship, because I know that that is a fraught, complex relationship and has been for some time. And the NoSQL talk just before me reminded me of something that I had to do recently, which was build a NoSQL injection demo. So I used Node and I used Mongo to create a NoSQL demo to show at a conference. And I had it all hypothetically set up right, and I couldn't get the damn thing to work. I spent hours trying to figure out why it wouldn't work. It should all work. I set it up. The vulnerability was there, as it should be. I couldn't get it to work. And it turns out that I couldn't get it to work because of the tool I was using. I was using Postman, which is a fairly typical API tool used by all developers when they're testing APIs, and it was an API vulnerability. And I didn't realize, as a developer, that it was pre-escaping all my strings for me. So it was sending my piece of information escaped. As soon as I went over to burp, work no problem, work first time. But I remember thinking to myself, this is a really good example of what's wrong with the relationship between developers and security. Even sometimes when developers know that something exists and are actively trying to test it, sometimes our tools are doing some easy stuff for us so that we're not getting the same kind of input. So I want to talk a little bit about some of the anti-patterns I've noticed and a little bit about how we combat it at the company we work for, but also to provide some context around some of the stuff that's happening and the way that things are changing. So one of the sort of main ones is obviously something we hear all the time, which is blame. How many people use git blame or know what it is? So git blame, if you use it, it tells you who made the last edit to a particular line of code. It gives you no other context around that change, but it allows you to pick someone to blame. That last change could have been the addition of a space. Maybe someone was fighting the latest battle in the Tab space war, who knows. But this gets at the idea that oftentimes the blame is misplaced. We're looking for the last person to do something, and we often miss the broader context of why something was done or what exactly that person was doing. This is something, and it's not necessarily this guy's fault, but this philosophy has really fundamentally changed the way we build web applications. The idea that we have to move as fast as possible and damn the consequences has really shifted the way we do development work, and it has a lot of consequences, both for the dev teams who are trying to build this stuff, for the businesses that are trying to keep up with other businesses that are building things faster, for the idea that we now have a dev supply chain that we have to keep track of, and also obviously for the security teams that have to try and help us protect the applications. This, in no small part, is one of the big reasons why package managers like NPM and the open source community has sprouted up in such a massive way, in particular with web applications. These kinds of package managers and open source solutions allow us as web developers to not have to write so much code, and it allows us to react much, much more quickly to the things that the business wants to add. It allows us to do it faster, it allows us to do it cheaper, and in a lot of situations, it actually does allow us to technically do it more securely and better with more bug-free code, because we're outsourcing some of the things we don't know to the people who have already done it well and potentially done it better than we could. But obviously there's a problem with this. We now have these massive dependency trees. So I wanted to kind of do a little experiment. I built myself like a really dead easy, simple clicker game out of Node, Vue.js, in part because I wanted to see what a really simple web application looked like on the back end from a dependency standpoint. So these are the dependencies that I added into my application. So there's not much there. We've got a tool that allows me to encrypt the password, basic framework using Express, some tools to manipulate Mongo. On the front-end side, we've got some basic tools, Vue framework, which allows me to do some front-end DOM manipulation, which is popular right now, as well as some tools to make some of that conversation with the API a little easier. This is the dependency trees that both of those things created, which is massive. That API backend, 282 lines from less than 10. Now, some of these are duplicated and have been deduped by the code, but that represents a massive amount of code that I didn't write, and to be frank, I had no idea I was including in my system. This also I found incredibly fascinating. If we look at the amount of code that I wrote, so for the API backend, we've got less than 1,000 lines of code that I wrote myself. But if we actually look at the number of lines of code that are being used in that application, or at least exist in that application, it's over 200,000. That's why we can build things quickly. But it also means that the vast majority of the code, I have no idea how it works. I know how to leverage it. I know how to call the certain bits of the library that I'm using, but I have no idea how it works under the hood, and I don't have time to learn it. That's why I'm using it. This is also something that really scares me. This is Express 4, Express 3 to 4, so this was a few years ago. For people who don't know Express, it's a kind of framework that you can put onto Node that makes a lot of stuff easier, but that means that it's baked into the core of your application. This is an open source tool. You don't pay for it, you just use it. But Express 4, when it came out in April 2014. If you track the dates, that gave developers 17 months to transition between Express 3 to Express 4. There are significant breaking changes between these two versions, and 17 months is not a lot of time if this is baked into the core of your application of any size. This is a big deal. This is something else. We'll notice that there's a depreciation notice here, and the depreciation notice was, I believe, in 2014. It is still, to this day, these were taken, this screenshot was taken about 6 months ago. It is still, to this day, the 47th most depended upon package on NPM, has not been updated since 2014, and it has had over 17 million downloads in the last month when I took this screenshot. So a lot of developers are using old depreciated code, and eventually there's going to be security flaws in some of this code. If not this precise package, then one of the other millions of packages that are hidden in people's codes and they don't even know that it's there. The other thing I want to mention briefly is that when you're building something as a developer, we talk about developers who write bad code, developers who write insecure code. But sometimes as a developer, when you're building something, you have to build it badly before you can figure out how to build it well. This happens all the time when you're developing a project. You make assumptions, you make decisions early on in the project. You'll notice if you look carefully, the sprint 1 on that big green guy's chest, that represents some error or some assertion that a developer made that turned out to cause a big problem later on in the chain and is now really, really difficult to fix. And to some extent, that's unavoidable. Some of that's always going to happen. One of the other things that I've noticed about the dev security relationship is what I like to call the special snowflake syndrome. We really, and I don't mean just the security people, I mean the entire business, and the developers, everyone involved in the creation of software, considers security to be special. Somehow you kind of sit above this process, you tell us, you give us a go, no-go at the end after you've had a look at something, and I think that's a huge problem. And in particular, as I've worked more closely with security people and learned more of this stuff myself, I have a lot better understanding of what's important. So I want to think about this just for a quick second. Who else that we know of in the IT system searches for these high-impact bugs that are often missed by dev teams, tests for minutiae of systems, is often shunted way far to the right of the life cycle, frequently acts as a gatekeeper or a bearer of bad news, is rarely invited to planning stages, rarely is represented or integrated all into a dev team, and often is the very first to get automated away by some sort of tool or new process. Anybody? Hey, absolutely. QA. Here's what I don't understand about security. Why aren't QA people your very best friends? QA people do a lot of what you do, but are not trained in security. And a lot of that, and QA is starting to get baked more and more into the process, and they can help so much if we can train those people. They're very clever. They know how to break systems. All they need to know is how to break systems in evil ways, not in the way that we would expect a sort of average user to break them. I just sort of did a quick Google of the way we make up agile teams, just to see if I could find any kind of picture or representation of an agile team, which is the way we build software now, that had security represented in it, and I found absolutely none. Every once in a while I find one with QA, which is great. I've never seen one with security, which tells me that in all this process, security is still seen as so far outside the process that nobody's ever asked you to come to the party, and also that security is not pounding the door to get invited to the party. There's also something that, as a developer, that drives me crazy about security. Who else in the company provides us really vague requirements, which at the 11th hour suddenly get real specific? They often need to see something finalized before they can provide any feedback or review. Rarely participates more than kind of superficially in any kind of planning, and tends to kind of single-mindedly pursue a very specific agenda without sort of thinking too much about other contexts or considerations. The business. These are all complaints that developers have about the business. And I'm sure that most security people don't want to be compared to the business. But to some extent, that's sometimes how security feels to a developer. It's just another set of no vague requirements that get real specific at the last minute, that we somehow have to hustle at the very end to try and figure out how we're going to meet these requirements when something's already built. Which leads me to another anti-pattern, which I'm sure we've all heard of before when we talk about moving left. This is security creep. Security creep is scope creep by any other name. And part of it is that the dev teams, the product managers, the project managers, nobody's inviting security to the party, and that's on us. But also, it's on you for not knocking on that door and trying to get to those meetings. QA didn't start showing up to those meetings until QA started to kick down the door, and to some extent, we need security to do the same thing. One of the things that happens when you get involved in the planning process is that you can do things like see what kind of tools we're using. You can see if we're using a mean stack or a lamp stack. You'll get that information early on. You get to see what kinds of things we're actually planning to build. You can look and see if we're using any novel new libraries or systems. You can ask for prototypes of those things. If you ask for that up front, it will change the priorities of the dev team to get that work done sooner so that they can give you a rudimentary prototype that you can start testing. We've all seen this graph before, and we know that security sits here. But one of the things that has always bothered me about this graph is on the left-hand side there, it says cost of change. And obviously, we know that if you move security far to the right, it impacts the cost of a project, because these kinds of last-minute changes are really difficult to make. But it also massively impacts our technical debt. Changes at the 11th hour never, ever, ever make code simpler, because you've got all this baggage that you now have to try and integrate around. So it does nothing but create technical debt and also creates risk later on. The farther right we have security, the more risk and technical debt we have in addition to added cost to the projects. One of the things that I've started doing with our team, in particular when we're looking for them to help us out with the actual security and pen testing of our applications, is once we have wireframes and we've started to have a clearer idea of what it is we're building, I make sure to share those wireframes with my security team. And I've kind of coined this as pen testing a wireframe. So obviously you can't interact with this in the same way, but it does allow you to kind of spot the things that maybe to your eyes look juicy. What on here makes you think, oh, that's risky? Or that would be the first thing that I'd start messing with. I showed my security team a wireframe that we were working on, and at that, we actually had someone spot an early DDoS risk for a reporting mechanism that we created just from the wireframe. And that allowed us to reprioritize that feature, because it was going to take us longer to build in order to avoid that DDoS risk. And we were able to bake that in early on and rejig our priorities and rejig the order in which we did stuff in order to tackle that earlier and take that threat more seriously. We never would have thought of it, and if it had been found at the last minute, we would have had a lot of work and a lot of technical debt in order to try and fix that error. I also want to talk a little bit about this idea of a code genie. We have enough kind of tech around us now that we both think of code as magic, that it's just something that we can do anything with. You can just wish something up and the code will make it work. But also, because it's so ubiquitous now, we've forgotten that this stuff can be really hard to do. It's not that easy, and sometimes things take time, and sometimes we have to build it bad to build it better. So there's a lot of lack of awareness growing as to what devs need to complete their job. And part of this is we're going in without doing enough pre-planning and without bringing the right people to the table to do that planning. I did some digging, and this was one of the pieces of information I found. So I know sometimes we hear about the lack of security people and how there's a bit of a skills gap, and there's lots of positions open, but not enough people with the skills to fill them. Development has exactly the same problem. If we look at this survey, which was done in 2016, we see that over 50%, just over, have 5 years or less experience in what they're doing. Is 5 years enough to have the expertise to build a scaling web application? Probably not. But that's who we have, because we have to keep building things, and those are the people that are available. So we've hired them. We try and train them when we can. We try and pair them with more experienced programmers. But some of these people are building their own businesses and building their own apps 2, 3, 4 years into having learned code. If you get into some of the newer tools that we're using, something like Node, which actually hasn't been around that long. So Node came into being around 2009, but it didn't really it didn't really pick up any serious use till about 5 years ago. And now it's become quite fashionable to use Node, JavaScript on the server, JavaScript on the front end, so that you only have to have devs that know JavaScript. But look at this. 82% of people, when surveyed in 2017, have 4 years or less experience using Node. And we are building entire applications out of this. So if you're looking for a developer who's got a minimum of 5 years experience in Node, you're looking for people that almost don't exist. I also really hate this myth of the full stack developer, this idea of chasing the unicorn. And I love the look on this lady's face. She's looking right into that face of the unicorn, and she's real skeptical. She doesn't believe it. She's like, I'm not sure I believe this claim. Let me put aside that mane and see if that horn's been glued on, because I'm not buying it. This idea of a full stack developer, a developer that can do all the tasks related to code. They can do the UI development. They can create and come up with the idea of the product. They can do all the front-end work. They can do all the back-end work. They can do all the database management. They can do all of the ops and all of the security. Those people don't exist. It's why we call them unicorns. It's because unicorns don't exist. They're real hard to find, and most of the time when you think you found one, it turns out someone's just glued a horn on a perfectly normal horse. We need to move away from this idea, not to say that people with generalist knowledge aren't important. These people are incredibly useful for us, in particular who can stand back and look at the entire stack and understand bits of it enough to understand how it's got to integrate together, where some of the risks are. But we cannot build a team of full stack developers, and we cannot build a business around full stack developers. They are an important part of the team, but they are not the team. We need those specialists to continue to exist. This is one of the reasons why security needs to come to the table. We need your expertise in the room to work with the team. The last major one I want to talk about is the hoarding dragon. If we think about dragons and we think about the idea that we have of dragons like guarding this pile of gold, does anybody know why dragons do that? I've never been able to figure it out. Like, why do dragons like sitting on that big pile of gold? What do they want it for? Shiny, I guess. Maybe they like shiny things. There's this idea with security, and in particular with large businesses, that security needs to kind of hoard its knowledge and hoard its expertise. They protect it very fiercely, and it's often framed, in particular inside dev teams, as this obstacle to overcome, in the same way that Bilbo Baggins has to find a way to trick Smaug, the dragon in The Hobbit, in order to get done what he needs to get done. He's got to either work around Smaug, or he's got to find a way to defeat Smaug. This isn't very helpful, obviously, in the dev process. And one of the things that I find interesting as I work with more security people, in particular new security people that come into our company, is they quite often feel like they need to dazzle me with their exciting terminology or their exciting experience. And I quite often like to dazzle them back with some sort of wacky front-end talk that I have, talking about some of the new technologies. Because it's a give and take. I have expertise, I have expertise that the security team doesn't have, and I also have a lot of context that the security team doesn't have. But I need my security team to give me all the context and expertise that they have, and I need them to share it with me both when I ask for it, and also in ways that I can easily understand without feeling like I'm kind of being, explained to, or that I have to try and keep up in some way. A really good example of this is one of the first projects I worked on had a file upload tool that I needed to build in. I had never done this before. It was just something that I never had a chance to do. And I knew that probably uploading a file from a user was probably a high-risk activity. So I wanted to know how to do it well. So before I did any coding, I messaged my security person on Slack, and I said, hey, I have this requirement. I got to build a file upload tool. What do I need to know? And this is what the initial message that my security person came back to me with. Very key, helpful pieces of information that I had asked for without any kind of extensive jargon. He spoke in my language, including knowing I was using PHP and knowing the specific things I should avoid, and places telling me the precise functions I should either use or not use. This was incredibly helpful for me. It wasn't the only piece of information he gave me. We had a long conversation and back and forth where we got a few more pieces of information. But I was able to take this and our conversation back and build something that was secure, that he could not crack later on. And that was great. That meant that I didn't deliver something that was broken later on. And this conversation also allowed me to trust that security person. I now go to that security person whenever I'm building something, if I even have the tiniest little inkling that something I'm doing might be risky or might have some kind of security context I need to know about. A really good example is I'm currently building a just local tool. It's not meant to go on any production environment. It's going to be completely isolated on my own computer in order to ping our database, in order to run some reporting that we need for a brief period of time on a weekly basis. And so I thought, oh, how am I going to do this? It needs to have like real database credentials for our production database because I need the production data. But I don't want to have to ping everything myself and then assemble a report later. I want to build myself like a little PHP script to do this for me so I can do it fast. And I thought, okay, well, obviously I don't want to put this in the code because if I ever put this in Git, I'll forget and then our credentials will be up in Git. That's no good. So I thought, I know, I'll put it in my own like little Vagrant server or my own little MAMP server, and I'll just add the credentials in as an environment variable. That'll work, right? That's how we do it on production servers. And then I thought, I probably shouldn't do this without asking first. I should probably check and make sure that this is sound. I think it's sound, but I don't know. Maybe there's something I'm missing here. And I messaged my security, same guy. I said, hey, this is what I'm thinking about doing. What do you think? He's like, I don't really want it on plain text anywhere on your computer. I said, well, my computer's encrypted. It's like, yeah, but it's only encrypted when it's one is turned off. So I said, well, how would you like me to do it? He said, if you could make it so that you have to pass it through every time, then the credentials only exist in RAM. I said, I could do that. It's a simple form. Every time I run the report, pass the credentials through, exists in RAM. As soon as it spits out the report, it's done. No problem, I can do that. But because I was comfortable enough going to that security person and saying, hey, here's my idea, where have I screwed this up? Where am I thinking about this wrongly? And his ability to reply to me and tell me exactly why and how I should go about solving it and what way that he would prefer that I solve the issue, that was incredibly helpful for me. And we have a great working relationship. Jargon's something we have to be really careful about. Jargon is incredibly, incredibly powerful. And different technical groups have different sets of jargon that you use for different things. One of the things that has been really helpful for me as a developer coming into a security-minded company is I really quickly learned all the security jargon, which when I'm doing development makes it real easy to do research on the security flaws that might exist in a new library because I know the lingo. A lot of developers have no idea what this lingo is. And jargon can be really useful. Jargon exists as a shorthand for us to be able to communicate more effectively and more quickly. But jargon can also be weaponized, and it's really important that we remember that jargon only works when the person understands what that jargon means. If they don't, then it's a power play, and it's a form of weaponization. Sometimes weaponizing jargon is helpful if you're trying to flash a business user into taking an action that you need them to take, and you don't have time to explain why. Sometimes that can be really powerful. But it's rarely useful with developers, and it's rarely useful to you in general as a form of weaponization. So just as I finish up, just some real quick tips for how to shift left, because I know we like to talk about this shift left and how we do it. So a couple of quick things. Remember that code is not a spectator sport. We have a security team that sometimes has to code things, and they're real bad at it. Oh, they're so bad at it. And they work with us, and we work with them, and we try and make their code better, and they help us make our systems more secure. But it's important that you know at least as much about the language as a brand new entry-level developer coming into your business. And in particular, the best thing that you can help me out with is learn all those really weird, kind of esoteric security quirks of my language that I have no idea exist. Preg replace is a good one. I now know that there's vulnerabilities in that in PHP. Never knew that before. RDOS risks in JS, that's another one I didn't know about. Another good thing is to know what your team's libraries and middleware does. Current development, in particular web app development, there's always a layer of middleware that assists us in making decisions and also doing things repeatedly and quickly. So as an example, validation these days for validating user input tends to live on a middleware layer because I don't want to create validation every time someone puts an input in. I want a library to do that for me. If it's a string that needs to be validated, I want to have a function that does that for me so that I never have to think about doing it. So if you know where those libraries and middleware are and you know how they work, that's a good place to start creating security by default rules. Because if those exist, people will use them. Also, we really need help selecting and building systems to manage our dependencies. Dependencies are not going away as long as we are going to continue to build things real fast. There's no way around that, at least at the moment. So what we need is assistance in how we select and manage those dependencies. So your help with that in that process early on is really valuable. In particular, if there's something that you want to test, if we're using a library that from your standpoint seems untested and makes you a little bit nervous, ask for a prototype. We can up a prototype of something that's got some inputs in it real fast. No problem. You can hack that for as long as you want. You can have months to hack that while we build the rest of the thing and tell us how it works. Ask for those prototypes, but you got to be in the room to know that it's relevant to you. Learn how to write tests. Test-driven development is a thing we're doing now. We try and write the tests first and then develop the tools that make those tests succeed. And there is absolutely no reason why you can't build security tests that we have to pass whenever we write new code. If those tests don't pass, then the code's not done and it can't be committed. Be as much a part of early stage planning as you possibly can, and even if you feel slighted by not being invited, kick in the door. That's how QA is getting to the party, and that's how design sometimes gets to the party. You got to do the same thing everyone else does, which is insist on being invited. And that includes being able to speak the language of the early part of development, which means being able to talk about business requirements, user stories, functional specs, that kind of stuff. But most importantly, this gives you the opportunity to put explicit, clear acceptance criteria in those functional requirements. If you look at something and you know that there's a risk associated with something like an API and it needs to be able to withstand X number of hits at X amount of speed at X time of day, whatever you need, make a functional requirement for it, make it an acceptance criteria, make it a requirement of the dev work, and it will get done. As I was saying before, pen test a wireframe. Look at those wireframes and give us feedback. Obviously, you can't fully pen test something, but even just your instinct on what looks juicy or what red flags that something instantly raises up can help us talk about it and discuss what needs to be done first or how we're going to protect that particular part of the application. I cannot say this enough, work with your QA team. They do a lot of the same kinds of work that you do. They do it with a different specialization and generally a different focus, but they can be your biggest ally in the process, and they are getting very, very good at moving left and talking with developers and working with developers and getting their goals across. This is one as well. Help us create useful, good, uncluttered logs. I once asked a security person who told me that I should do some more logging. What logs would you like? And they said, log everything. I'm like, you don't really want that, do you? You don't want me to log actually everything. I can, but nobody wants that. So tell me what you need. If you're forensics, if you're watching a SOC, if you want to have access to that log information, tell me what should be in the logs, but also what information shouldn't be in the logs. Should user IDs be in the logs? Should emails? That's a piece of information you can help us out with. Remember that your suggestions and your timing have massive impacts on the business and the development team beyond just security. In particular, security changes rarely make code simpler or easier to understand, and tired, overworked developers write worse, riskier, security-flawed code, even if they're trying to fix existing flaws. Back-ending risk is just another form of scope creep. And this one drives me crazy as someone who has recently spent a lot of time helping support teams out. I totally get why we want things when you're typing a username and password to create things like really opaque, consistent errors so that you can't tell when you've got a user ID. I get the security implications there. But sometimes these opaque error messages cause a whole bunch of problems down the lane in security because we're not telling users what action to take or what's actually wrong. And if they can't figure it out, the very first thing they're going to do is find the support email and go yell at someone in support. So all we're doing is moving that problem onto someone else's plate. There are other ways that we can solve those issues, and we need to think of the wider context when we request some of these changes to UIs.